Okay, so we're going into ascending order. So we're doing big things go that way and small things go to the left of the pivot. So first pivot, 1, 3, 4. Things that are less than 1, 3, 4 is nothing. So 1, 3, 4 here, now fix, followed by 650, 4, 3, 1, 2, 4, 5, 6, 4, 3, 4, 5, 5, 7, 10, 2, 3, 4, 1, 6, 2, 4, 5, 2. Okay, next pivots are 4, 5, 5 is in the middle. So things that are less than 4, 5, 5 are this and this and this and this and this, in fact, everything. So they go to the left, 4, 3, 1, 2, 4, 5, 2, 3, 4, 1, 6, 2, 4, 5, 2. Then 4, 5, 5, which is now fixed. Then we have 650, 6, 4, 3, and 7, 10. So we can now pivot 6, 4, 3, and 2, 3, 4. Things less than 2, 3, 4, just that one. Things less than 6, 4, 3, nothing. So we get 1, 6, 2, 2, 3, 4, now fixed. 4, 3, 1, 2, 4, 5, 4, 5, 2. Over this side, 6, 4, 3, now fixed, 650 and 7, 10. So we can now pivot 7, 10, and this is on its own, so that could be fixed, and 2, 4, 5. Things less than 2, 4, 5, nothing. So 2, 4, 5 can go here fixed, followed by 3, 4, 1, and 4, 5, 2. And things that are less than that is 650, so 650 goes here, 7, 10 goes here, now fixed. 650 is on its own, so it can be fixed. We have to pivot the 4, 5, 2, keep the 4, 3, 1 to the left, fix the 4, 5, 2, that's on its own, so it's now fixed. Sort complete. Wow, that took ages. Okay, bubble sort. Okay, so we are now going, we're doing ascending again, so we're going to have big things going this way. So the 650 can go all the way up to here, and then it gets blocked by the 710. So that's 4, 3, 1, 2, 4, 5, 6, 4, 3, 4, 5, 5, 1, 3, 4, all moving to the left. Now the 7, 10 can go all the way to the end, 2, 3, 4, 1, 6, 2, 4, 5, 2, all move out of the way. 4, 3, 1 can only move one space. Then the 6, 4, 3 can go, but that can only go up to here. 4, 5, 5, 1, 3, 4. My numbers are merging together, it's dangerous. My 650 can go all the way over here and is now fixed. Moving 2, 3, 4, 1, 6, 2, and 4, 5, 2 out the way. Okay, 2, 4, 5 can't move. 4, 3, 1 can't move. 4, 5, 5 can move, but only one place. 6, 4, 3 can actually go all the way to the end and get fixed. So then the 2, 3, 4, the 1, 6, 2, and the 4, 5, 2 move to the left out the way. Okay, 2, 4, 5 still can't move. 4, 3, 1 can move, but only one place. 4, 5, 5 can go all the way to the end. So what's moving? 2, 3, 4, 1, 6, 2. Oh my goodness, 4, 5, 2 all moved out the way. That one's now fixed. Okay, 2, 4, 5 now can move, but only one space. 431 can move to here. Then the 2, 3, 4, and 1, 6, 2 move. 4, 5, 2 can't move, is now fixed. 1, 3, 4 can't move. 2, 4, 5 can move to here. The 2, 3, 4, and the 1, 6, 2 move out the way. 4, 3, 1 can't move, is now fixed. 1, 3, 4 can't move. 2, 3, 4 can move one place. 2, 4, 5 can't move, now fixed. 1, 3, 4 can't move. 1, 6, 2 can't move. 2, 3, 4 can't move, now fixed. And that was A, full pass with no swaps. So, this sort is complete. Smiley face isn't necessary. Okay, we are now going to do a binary search. So first thing we need to do is get them in order. So there are 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 240 for 5, so we reject 4, 5, 2 and below. That leaves us with numbers, so that's all of these now rejected. Okay, 1 add 5 over 2 equals 3, which is 234, and we want something bigger than that, so we reject 234 and above. So that is all of these now rejected. 4 add 5 over 2, which is 4.5, which goes to 5. Number 5 is 431, and we want something smaller than that. So we reject 431. We don't need to reject anything else because 431 is just on its own there. You could reject and below if you want, but you don't need to. That leaves us with a list of 4 add 4 over 2 is 4, so that is 4. So the fourth one is 245, so 245 has been found. Hooray. Okay, a bin pack. So we are going to do a first fit. So essentially, because of the change of units here, what we've got is 1,000. So we're going to put, we're doing first fit decreasing. So we put the biggest one in first, 710. So that goes in here and that leaves us with 290 spare. The next biggest one is 650. That's the next biggest one, so that's going to have to go in its own bin. So that leaves us there with 350. The next one is 643. Again, that's going to have to go in its own bin because it won't fit in the others. That leaves us with 350. Actually, can I afford 357, sorry, can't add in my head. Right, next one is 455, that's the next biggest. So that one's going to have to go in its own bin. That leaves us with 545 spare there. Okay, next one is 431. No, it isn't. It's 452 even. Okay, now 452 can actually fit in this one, leaving 93. Then the next one is 431, which has got to go in its own one, leaving us with 569 there. Okay, next smallest is 245, which can fit in this first one, leaving us with 45 there. Next smallest, 234, can fit in here, leaving us with 116 there. Next smallest is 162. 162 can fit in this one, leaving us with 195, I think. And then the last one, 134, can fit in here, leaving that one with 61. Okay, so we're going to start at A. So we're going to do a T for at the top there, and then we're going to remove A, and then we're going to circle the smallest under A, which is 48. And then as soon as we do that, we write down A, B, to get the list. The list is what's important. Now, having got the list, we're going to go back to T. So we're going to label B as number 2, remove row B, have a look down those two. The smallest is 55. So 55 is GB, and then we're back to T. So what we introduced? G. So G came in third. If we look down, the smallest is now 63, which is BF. So F came in fourth. And now the smallest one now is, under A I've got 117 and 92. Under B, I haven't got anything. I've got 132 and 124. Under G, I've got an 85, and that's the smallest. So that's GC, 85. So C is coming in fifth. Remove that row there. Okay, the next one that we've got is, next smallest is 28, which is DC, 28. So D has come in sixth. And we can remove row D, and then finally the smallest way to get E in is 58, so that's DE. and then that's coming 7. There we go. So the network looks like, or the tree, the minimum spanning tree. I don't think we were asked to draw this, but anyway, you've got A, B, you've got G to B, you've got G to C, you've got B to F, C to D, and E to D. So that's minimum spanning tree, and the total weight is 337 units. They haven't said any units in this question. Okay, Kruskal. So the first thing we need to do is put them in order. So I've already done that, so I'll just copy that down so you can check yours. AC 15, BD 16, AB 17, AD 18, EG 20, FG 21, BE 24, CF 25, DG 32, and CE 35. Okay, so we start by adding AC. Is that one added? And EF I meant. EF, that one. And then AC. So those two are added. We can add BD, that doesn't create a cycle. Then we can add AB, that doesn't create a cycle. Then we can add, no, we can't add AD, we reject AD, because that creates a cycle. E to G, we can add. And F to G we can't add, because that would create a cycle. B to E we can add, and then we're done. And the total weight is 106 meters or whatever it is. Okay, same thing but prim starting at F. So if we start at F and we want to bring something in, the cheapest thing we can bring in is E. So if we join E to F, that's a distance of 14. Now we've got a choice. We could bring in C at 25, C at 35, B at 24, G at 20, G at 21. And G at 20 is the cheapest. So GE 20, that's the next cheapest. Okay, we can now bring in C at 25 or 35, B at 24, or D at 32. So the cheapest is B at 24. So that's BE 24. Now we could bring in D at 16 or 32, A at 17, or C at 35 or 25. So the cheapest is D at 16. So that's BD 16. And now the cheapest thing is A, bringing that in at 17, AB 17, and then finally bring C into A on 15. And it's the same spanning tree we got with Kruskals, and the total weight obviously is the same, 106. Right, so we start at the beginning. A is 0, X is 54, I'm going to have to use 2 lines per line I think, and Y is 63. Is X even? So we're coming down here and we're at the question, is X even? Yes, it is even. Okay, so because yes, it is even, we now divide it by 2, giving us 27, and then we follow this down, we double the Y, so double Y is 126. And then we follow that round. Is X even? No. X is not even. Okay, so that follows this way now. So we get A is A plus Y. So A is now going to become 0 plus 126, which is 126. Follow this down. X has 1 taken off it, so it's now 26. Is X 0? No. X is not 0. Okay? So we're back here. X gets divided by 2, 13, and then Y gets doubled, so that's 252, and then we get, is X even? X is not even, no. So then we have to do A add Y, so that now becomes 378, and we just keep following it round. So we should have a 12 here, and then no. And then this goes down, to 6. Oh yes, it gets halved. What am I talking about? Halved. So this goes down to 6. Then this goes down to 504 because it gets doubled. Then yes, it is even. So then this gets halved to 3. And this is 1008. And I think I've done this right. And then this is no. Was that yes? Okay, I think I've done this right. No. And then this is 1386. And then this is 2. And this is no. And then this gets halved. And this gets doubled. And this is no. And then this is 3402, and this is now 0, and this is now yes, finally. I think that's right. So what does this do? It produces a product, basically. Product of 54 and 63. I'm not sure how you kind of work that out, really. It's not obvious to me why it's the product, but it is.